A very close cousin of overloading methods is called overriding methods. In overriding methods, you basically get to change or augment the behavior of methods in classes, and this is called overriding their logic. It's one of the most powerful things of object-oriented programming, and it really, really helps you when you want to encapsulate your logic in your objects and separate the behaviors of different objects from each other. Let's suppose you have a phone. And a phone knows how to do something like ring. But of course, you don't just have a phone, you have a particular type of phone. You might have a landline, you might have a cellular, you might have a satellite phone. Well, each one of those knows how to ring as well. In fact, they've got their own custom ways of ringing. Now, when you get a phone call, the person calling you doesn't necessarily know what kind of phone you have. All they know is that you've got a phone. When they make a phone call, the system looks up your phone and tells your phone to ring. And when the phone is told to ring, it figures out what kind of phone you have, and it tells that particular kind of phone to go ahead and do its ringing. And this is the same kind of concept that we'll do in object-oriented programming. You'll have a class, a subclass, and the base class, or the superclass, to use object-oriented terminology, will have some method in it. And you want to either completely replace the logic that's in that method, or you want to augment it somehow. You use overriding in order to do this. Now, there's three important things you have to understand. There's three keywords in C#. The first one is virtual. The virtual keyword tells the compiler that it can be overridden. The override keyword is another important one, and then there's the base keyword. To use the overriding mechanism, there's three things you have to do. First, you have to mark a method as being virtual. This tells the compiler that this particular method can be overridden by derived classes. If you're coming from other languages like JavaScript or C++, this may look somewhat familiar, but it's a little bit different. You have to specifically mark a function as being overridable. So here you can see I've got a function called myFunction. It returns an integer, and I've got the public keyword in front of it, but I've inserted the word virtual between the public and the return type. This tells the compiler, hey, somebody might want to override this. Now, they don't have to, but they might want to. To actually override the method, in the subclass, I tell the compiler that a particular method is going to override the same method in the base class by using the override keyword. So in this case, instead of virtual, I use override. And you can see I've done the same thing here. Between the return type and the word public, I've used the word override. And these two go hand in hand when you want to override methods. And then finally, there's the base keyword. And you can use this in your subclass to call the base class's method. And you use this because you don't necessarily always know what the name of the base class is. Instead of actually using the name of the base class, you simply say base dot whatever the function is. And this will call into the code in the superclass instead of your subclass. I know this is a little bit complex. It's probably helpful to see an example of this in action. So let's jump over to the code and see it work. Okay, so here I am in my example. This is for method overriding. And I'm going to go over to my snippets. And you can see in my snippets, I've scrolled down to the overriding methods section. The first thing I'm going to do is copy over my class definitions. I have two classes. I have one that's a base class, and I have one that is a subclass of that base class. Let's go ahead and copy these over. And I'll put these in my program definition here. So now I'm going to scroll back over here, down a little bit. I'm going to copy this code and put it into my program. Before we run this, let's take a look at the class definitions so we can see what's going on. In my base class, you can see here on line 10, I've got a function called doSomething. And it doesn't return anything, so it's a void return type, and it's public. And I've declared it as a virtual method. And what that means is when I create a subclass that descends from this base class, the subclass has the opportunity, if it wants to override this method. Now, the base class method for doSomething just simply writes something out to the console. It says, hey, this is the base class saying hi. Go down to the subclass. On line 18, you can see that I've got the same method, doSomething. In this case, I've got the override keyword. So this tells the compiler, hey, I'm overriding whatever the base class does. In the do something method for the base class, I'm calling the base class's version of do something, which we'll call the console.writeLine method. And then I can put on whatever additional programming logic I want to. I can do another console.writeLine. I can put it before or after the base class call. I can put it here if I want to. I'll just leave it there for now. So let's go back down to the program. And you can see that what I'm doing is I'm creating an object. I've got a subclass object. I'm going to create a new subclass object called obj1, and I'm going to call do something. So let's see what happens when I run this. Two things get written out. This is the base class saying hi, and this is the subclass saying hi. So why did that happen? Well, in object1, we call do something. Object1 is a subclass. So we look in the subclass, and you can see that in do something, the first thing we do is call the base class's version of do something, which will be this right here. The base class saying hi gets called first, and then that returns, and then the subclass gets called. We can reverse that order. We can cut this line and put it up here, and let's run it again. And now you can see that the subclass says hi first instead of the base class. Okay, let's go back to the code. We can actually just take this call out. We don't have to call the base class if we don't want to. Now we've completely replaced the functionality that the base class provides, and we're only doing what the subclass says to do. So we're going to save this and run it. And now you can see that only the subclass's version of that function is running. The base class's version is not getting a chance to run. Hit return. Okay, let's try something else. Since subclass is a version of the base class object, I can do something like this. I can say base class obj1 equals new subclass. Now that may seem strange at first because, wait a second, shouldn't I be creating a new subclass? No, I'm actually going to create a base class object. Let's see what happens here. This is the subclass saying hi. Why did that happen? Why is it that when I created an object of type base class, or I gave it a name of base class, and I created a new type of subclass, why did it not call the base class's version? Why? Because when you create a virtual function, C# is actually going to look up what the lowest descendant is and call that version of the function. Since I actually created a new instance of subclass, even though I arranged it to be assigned to a variable named base class type, it's still going to look down in the functions and say, oh, you know what? That subclass object is actually overriding this function, so I'm going to call that version instead. Let's change this so that instead of creating a new subclass type, I'm creating a new base class type. Now let's see what happens. I'm going to run it. Now it's the base class's version saying hi. Why? Because it's not a subclass anymore. It's a base class now. That's how you override methods. You use the keyword virtual to indicate that a method can be overridden, and then use the override keyword to indicate that you are overriding it in a base class. And you can use this to augment the functionality provided by base classes in your own programs as well as other programs that you might be adding on to. It's a really great way of segmenting your program so that pieces of functionality don't have to be changed in base classes in order to provide new pieces of functionality in classes that derive from them.